Alright, in this video I'm going to use the rational root theorem to factor the function and find all zeros. So typically with these problems it's just going to give you the directions, factor the function and find all zeros. So we're given f of x equals x to the third plus 4x squared plus 5x plus 2. So since I'm wanting to find zeros, we're going to set this equal to 0. So we're going to have 0 equals x to the third plus 4x squared plus 5x plus 2. So if I want to use the rational root theorem, before I get to that, I would first try and factor this problem. So if it can be factored, we would go that route and we would not even need to use the rational root theorem. But you would try and factor first. And if you're not sure of the various ways we could factor, that's in all my previous videos. But looking at this cannot be factored. I would maybe try a factor by grouping, but that's not going to work. So since factoring can no longer work, what we're going to do is we're going to use the rational root theorem. So first thing I'm going to do is I'm going to list out all possible zeros that it could be. And how we do that is we're going to do P over Q, where first we're going to start with P. We're going to make a list here, and this could be a positive or negative list. P comes from your constant, which in this case was 2. So we want all factors of 2. Well, the factors of 2 are 1 and 2. So we're looking for things that multiply to 2. Next thing we need is we're going to find the denominators of here, which is our Q. Now Q comes from your leading coefficient of the entire polynomial. In this case, it's not written, but it is 1. So factors of 1 are just 1. So we're going to have P divided by Q, well, we're going to have 1 over 1, 2 over 1. So in general, my P over Q list, my list here is just going to have 1 divided by 1, which is 1, and 2 divided by 1, which is 2. So I have positive, negative, 1, or 2. The goal from here on out is this is a list of all possible zeros of the function. Obviously, it's a possible list, so not all the zeros, or not every single number here is a 0, but my zeros should be, the real ones will be there. So there is a way that we're going to kind of use this list and kind of get ahead, is we would have to go through, we'd start with positive 1, then do negative 1, then positive 2, then negative 2. Since we're allowing a graphing calculator, you can use that to kind of start the process a little bit quicker. So what you can do is plug in your calculator, the function, which I have already typed mine in, and you can graph it, and we'll learn about graphing here later on. And more importantly, I'm going to look at the table. So I'm going to do second table. And looking at this list, what I'm looking for is what x values give me a y value of 0. So one of them I notice negative 1 gives me 0. Notice how negative 1 is in my list, negative 1. So what I'm going to do is I'm going to start with synthetic division. Negative 1 is going to be in the box, and I'm going to take coefficients here. So I'm going to have 1, 4, 5, 2. What we're going to do is we're just going to do synthetic division with negative 1. So you add down the first one, multiply by negative 1, multiply up, add down, we get 3, multiply up, we get negative 3. Add down, you get 2, multiply up, you get negative 2. Add down, and you get 0. So what you get there is we got a remainder of 0. Now, remember back earlier in this chapter that when we did synthetic division of a polynomial and we got a remainder of 0, that meant that we have found a factor. So since I used negative 1 in my box, my factor associated with that is going to be x plus 1. Now, so I found one of my factors of this polynomial. Since I couldn't factor it earlier, I know one of them is x plus 1. My remaining pieces here is I have, since that was an x cubed, that is a 1x squared plus 3x plus 2. And this is all still equal to 0. So what I want to do here is, now that I found one factor, which is great, I'm going to go ahead and try and factor this. So looking at this, I'll look for two numbers that multiply to positive 2, but add to 3. So two numbers that multiply to positive 2, but add to 3. So the two numbers are going to be positive 2 and positive 1, because those multiply to 2 and add to 3. So I have x plus 1, x plus 2, x plus 1. Those are my three factors, and we're going to set that equal to 0 still. So what I have done is I took a function, my polynomial, that originally could not be factored. You could try and factor it, you're not going to be able to. But then I used the rational root theorem, which is this P and Q, to come up with a list of potential zeros. Using this, I found one that worked. So instead, since I found one that worked, I found me a factor. So originally I had no factors, no way of factoring it, to finding a factor. And what in turn it did is it allowed us to get a function that I can continue to factor. So now I have factored the polynomial completely. So once it's factored completely, the only thing left to do is to find zeros. So I'm going to take each of my individual factors, set them equal to 0, and solve. So I have x plus 1 is equal to 0, x plus 2 is equal to 0, and x plus 1 is equal to 0. When I solve each of those individually, I'm going to get on this first one, x is negative 1. Second one, x is negative 2. And the third one, x is negative 1 again. So each of those is my zeros. So that was a basic problem using the rational root theorem.